Hello students, welcome in Science and Technology Part 1, 10th Standard. I am Mahesh Jayappa from Lathe Education Societies, Srimati Rajmati Nemgonda Patil Girls High School and Junior College. Students, from Science and Technology Part 1, we are going to learn the second topic, periodic classification of elements. In this topic, we are going to study about the different content as we are mentioned in the topic, and these contents are elements and their classification, Doberan's law of triad, Newland's law of octave, Mendeleev's periodic table, and modern periodic table. Students, we are going to learn this topic in different parts. In the first part, we are going to study up to Newland's law of octaves. So, let us start the topic periodic classification of elements. Students, we know still now different elements are discovered and their properties are already mentioned. But in the previous time, it was very difficult to classify the elements to study in a scientific way. So, at that time, there was a need to classify the elements in a scientific way. Different scientists worked on it, and some of the scientists put forth the framework for the classification. Around year 1800, only about 30 elements were known. More number of elements were discovered in the course of time. More and more information about the properties of these elements was gathered. To ease the study of such a large number of elements, scientists started studying the pattern, if any, in the vast information about them. In early case, the elements were classified as metals and non-metals. But later on, some elements showed the property of both metals and non-metals are called as a metal. As the properties of elements went on increasing, scientists were started trying out different methods of classification. Out of that, different scientists who worked on the classification of elements, and they are finding some classification methods according to their knowledge. Out of that, first, Doberan's triad is one of the important classification was put forth by scientist Doberan in 1817. In the year 1817, a German scientist Doberan suggested that the properties of elements are related to their atomic mass. He made group of three elements such having similar chemical properties and called them as a triad. And from that information, he stated a law further known as Doberan's law of triads. Doberan's law of triad was states as when the elements in the triad are arranged in an increasing order of their atomic mass, it is found that the atomic mass of the middle element was approximately equal the mean of the atomic mass of the other two elements. Means in triad means having three elements which are arranged in their increasing order of atomic mass are showing same chemical properties, but in that triad he arranged the elements in such a way that the atomic mass of the first element and the third element, if it is calculated and its arithmetic mean was done, then it is equal to of the second element's atomic mass. And from that he suggested some triads, for example lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine, iodine are some of the triads are mentioned. Here we are seeing some examples which are already mentioned. First example is the lithium, sodium and potassium triad. In the chart we are seeing that lithium is having atomic mass about 6.9, sodium is having atomic mass 23, potassium is having atomic mass 39.1. In the fourth column we are seeing that if the arithmetic mean of the first lithium and last potassium is done, it is found that it comes up to 23, and it is nothing but the atomic mass of the middle element, which is sodium, having formula Na, and it is found to be as a 23 as a correct. So it is one of the example of the triad. Likewise we have seen second triad calcium, strontium, barium. Here we are seeing that calcium is having atomic mass 40.1, then barium is having atomic mass 137.3, and strontium is having mass about 88.7. If we are doing the 87.6, if we are doing the arithmetic mean of first and third, it is found that about 88.7 was the arithmetic mean of first and third element. So it is near about that. So likewise we are seeing also chlorine, bromine, iodine triad, which is showing the follow of the Doberan's law of triads. Doberan's law of triad are also having some limitations, and it was that when the elements are known at that time, only few of the elements are following the law of Doberan's law of triads. Now we are going to study the Newland's law of octave, which was put forth by the scientist Newlands as a classification of the element. In the year 1886, English scientist John Newland, considering the atomic mass as a unit for the classification of element, he arranged the elements in an increasing order of their atomic mass. He started with lightest element hydrogen and ended with thorium. From that, he stated the law of octave known as Newland's law of octave. Newland's law of octave, it states that every eighth element had properties similar to those of the first element. In the following table, it is found that sodium is the eighth element from the lithium, and both of them are having same properties. In the similar way, carbon and silicon, sodium and potassium, magnesium and calcium are having same properties. Here in the chart we are seeing that is the sodium is the eighth element from lithium, and that is why both are showing the same chemical properties. Magnesium is also having the same chemical properties with respect to beryllium, and likewise every eighth element from its first element, they are showing the same chemical properties. Limitations of Newland's classification. Though limitations are seen in Newland's classification, it is found that this law applicable only up to the first few elements, that is up to calcium. Newland's octave did not have provision to accommodate the newly discovered element. Students, if the new elements were discovered during the course of time, there was no provision is done for new elements in Newland's law of classification of elements. Newlands placed the two elements each in some boxes to accommodate all known elements. Sometimes what happens? Newlands placed some elements, that is two elements in a single box. But already we know that the elements are arranged in an increasing order of their atomic masses, and single element was placed in a single box. But some problematic views are seen in that cobalt and nickel, Ce and La are, that is cesium and lawrencium, are placed in a single box, and so it was the limitation according to Newland's law of classification of elements. He placed some elements with different properties under the same note in the octave. What he made? Sometimes elements which are having different properties, they are placed with together in a single box. For example, cobalt and nickel under the note with the halogens. Here we are seeing one of the limitation of Newland's octave. In the first chart we have seen that is the only octaves are mentioned, but now we are seeing that one of the limitation is seen, that is the elements are placed with a single note in the chart. So here we are seeing cobalt and nickel are placed in a single box, while Ce and La are also kept in a single box. But already we know that elements are placed in a single box with a single element, and that was the limitation is seen in Newland's classification of element, that is Newland's law of octaves. Here we are finding that the elements though are placed at that time, they are very well work was done by Newlands and Doberanner with respect to the information available at that time, and so we are seeing that the elements which are known at that time, they are very well put forth by the framework of the Doberanner and Newland, and that was the framework for the classification of elements, or that is the starting work for the classification of the element. Students, we are stopping here as the first part of second topic, periodic classification of elements, and we have studied up to Newland's law of octaves and its limitation. So thank you very much. We are going to study the next part of the topic in next video.